We look at the classification of matter, we can see that solutions fall under mixtures, and they are homogeneous mixtures in which everything looks the same. Now, a solution has two parts to it. The first part is a solute. The solute is what is dissolved into the solution. Now, these examples, they don't all have to be with liquids. Gases can dissolve into solids. Gases can dissolve into liquid. Gases can dissolve into gases. Solids can dissolve into gases. It just depends on how you're looking at it. But our examples, we have salt in salt water, sugar in soda drinks, carbon dioxide in soda drinks. We have the idea that like substances dissolve like substances. So nonpolar solutes dissolve best in nonpolar solvents. And so when we have something that's nonpolar, it's usually an organic molecule. So we're looking at fats, steroids, and waxes as being our solutes, and our solvents would be benzene, hexane, and toluene. Polar substances are inorganic salts. Sugar is a polar substance even though it's organic, and those will dissolve in water, alcohols, and acetic acid or vinegar. When we look at our solubility trends, we'll see that the solubility of most solids increase with temperature, and the rate that the solids dissolve will also increase with surface area. So if you think about tea, and we want to have sweet tea, we want to put our sugar in when it's hot, and we want to use small pieces of sugar, not large pieces. The solubility of gases decrease with an increase in temperature, and the solubility of gases will increase with the pressure above the solution. So when they're going to put carbon dioxide into soda pop, they make the temperature very low, and they also increase the pressure that they're putting the gas into it with so that the carbon dioxide will dissolve better into the solution. Solids will then tend to dissolve best when they're heated, when they're stirred, and when they're ground into small pieces or particles. So we'll see that the smaller the sugar crystals, the better it would dissolve. Gases tend to dissolve in a solution that is cold and the pressure is high. This is a solubility chart. You'll see that almost everything increases as we increase temperature. And what we have here is this can tell you how many grams of our solute can be dissolved in 100 grams of water in this case. When we talk about saturation, we have three terms that we look at. We can look at a saturated solution is a solution that contains the maximum amount of solute that can be dissolved under the existing conditions. An unsaturated solution has less than that maximum amount. The existing conditions are temperature and pressure is what we would look at. A supersaturated solution is a solution that contains more solute than it should under those normal conditions. If you've ever made rock candy or hard candy, you will have done this exact same thing of making something supersaturated. You take your water and your sugar and you keep adding water and you heat it up and you heat it up and you're driving off some of the water at that hot temperature, and then the sugar becomes supersaturated as it cools down, and then when you put a crystal in, you can grow rock candy, or if it's hard candy, you get to set up, and if you don't get to supersaturated, it won't set up and be completely solid.